Welcome to the Deep Dive. Today we're launching into something that, well, just captures the imagination, doesn't it? Space travel.
It really does.
From those first steps on the moon, those grainy images, to these futuristic visions of Mars colonies. It just keeps pulling us.
Absolutely. It's a constant forward motion.
So in this deep dive, we're kind of looking at two tracks, right? Two ways humanity's reaching for the stars.
Yeah, distinct but connected.
On one side, you've got NASA, big plans, serious science, exploration.
Pushing the frontiers.
And then there's this other thing happening, commercial space tourism. Exploding, really, but also, people have opinions.
Definitely raises questions.
Our sources for this are pretty solid. We've got stuff straight from NASA, a big overview of space tourism from a public knowledge base, and an economic breakdown from a business intel firm.
Good mix.
And our mission really is to pull out the key stuff, maybe some surprising bits, and just help you get a handle on what's shaping our future out there. The shortcut to sounding smart about space.
Without getting lost in the woods.
Exactly. Okay, let's start with NASA's vision then. What our sources show is it's not just about planting flags, is it? It's about learning, about figuring things out once we get there.
That's the core of it. Exploration and science.
And this plan to go back to the moon, specifically the lunar South Pole, by 2024. I mean, that date might have shifted a bit, but the goal, the South Pole. Why there? And what's this whole stay thing about?
Right, the staying part is key. The South Pole. Well, the thinking is there's water ice there in these craters that never see sunlight.
Water ice, okay.
Yeah, and if you have water, you potentially have drinking water, you have oxygen to breathe, and you can even split it into hydrogen and oxygen for rocket fuel.
Wow, okay, so it's like a cosmic gas station.
Sort of. It changes the moon from just a place to visit into, base camp, a proving ground, and maybe even a supply stop from Mars. That's the long-term idea.
And the tech to do this. I
Yeah.
mean, the Space Launch System, the SLS.
Yeah.
Biggest rocket ever built. 364 feet tall, lifts 115 tons. That sounds pretty essential.
Oh, it's absolutely fundamental. You can't do sustained deep space human missions without that kind of heavy lift. Think of it as the absolute workhorse.
So it carries the Orion spacecraft, which is for the astronauts.
Right. Orion's the deep space vehicle. And then you've got the Gateway, this command module that'll orbit the moon.
Orbiting the moon. So like a space station near the moon.
Pretty much. A staging point.
It's a point.
Makes going down to the surface and back easier, more sustainable. You need all those pieces, SLS, Orion, Gateway for this whole let's stay on the moon plan to work.
Okay, so that's Moon and Mars prep. But NASA's also looking way out, right? The James Webb Space Telescope. I mean, everyone's seen those images. What makes it such a big deal? It's a collaboration too, right?
Huge deal, yeah. With the European and Canadian space agencies, Webb is revolutionary because it sees primarily in infrared light.
Infrared. So it sees things Hubble couldn't.
Exactly. It can pierce through the dust and gas that obscures visible light, so it lets us see, the very first stars and galaxies forming after the Big Bang. Yeah, it's like looking back in time. Plus, it studies exoplanet atmospheres, looking for potential signs of life. It's just giving us a whole new view of the universe.
And then, going from the super distant to the super close, the Parker Solar Probe, literally touching the sun. How does that even work? Getting within 4 million miles, wouldn't it just melt?
It sounds impossible, doesn't it? It's an incredible piece of engineering. It has this amazing heat shield, a thick carbon composite shield that reflects most of the intense heat and radiation.
A giant sunshade, basically.
Kind of.
Yeah.
And a sophisticated cooling system, too. It lets it fly through the sun's outer atmosphere, the corona, and sample the solar wind directly. Gives us amazing data on space weather, which actually affects us here on Earth.
Right. Space weather, solar flares and stuff.
Exactly. So understanding the sun better helps protect our satellites and power grids.
But it's not just outward bound, is it? NASA still does a ton of Earth science.
Yeah.
Our sources talk about satellites, planes, ground observations, keeping an eye on our own planet.
Absolutely vital. It's easy to forget with all the Mars talk, but understanding Earth as a system is a core NASA mission.
Like Landsat 9, launched in 2020. What's its job?
Landsat's been going for decades, really. Landsat 9 continues that legacy. It monitors the Earth's land surface, tracking changes over time, deforestation, urban sprawl, agriculture, water resources.
So it helps us see how we're changing the planet.
Precisely. It distinguishes between human impacts and natural changes. That data is critical for, managing resources, planning land use, things that affect everyone.
And then there's SWAT. Surface water and ocean topography. That sounds really specific.
It is. SWOT's making the first global survey of basically all the surface water on Earth.
Hmm?
Lakes, rivers, reservoirs, and the oceans, of course. It tracks how these water levels change.
Why is that important?
Think about managing dams, planning shipping routes, understanding flood risks, tracking drought,
Yeah.
and how climate change is affecting all our water resources. SWOT gives us that global picture.
Got it. And CYGNSS, that sounds like it's about storms.
Yeah, CYGNSS Cyclone Global Navigation Satellite System. It's actually a constellation of 8 small satellites. They use GPS signals bouncing off the ocean surface
Okay.
to measure wind speeds inside hurricanes and cyclones. This gives us a much better, earlier look at storm intensity and track. Really important for forecasts and warnings.
So what really strikes me here is NASA isn't just about, aliens and rockets. They're developing tech that changes things back here, that innovation loop.
That's a huge part of their mandate, and often an undersold one. Aeronautics is a perfect example.
Right, making planes better, like the Quest-E program.
Yeah.
Quite supersonic technology.
Exactly. The goal of that X-plane, the low-boom flight demonstrator, is to figure out how to make supersonic flight quiet enough to be allowed over land. Reduce the sonic boom to more of a sonic thump.
So faster flights without annoying everyone on the ground.
That's the idea. Plus, reducing fuel use and emissions. It could genuinely revolutionize air travel if they crack it.
And the X-57 Maxwell. That's the all-electric plane.
Yeah, NASA's first all-electric X-plane. The goals are pretty wild. A 500% boost in high-speed cruise efficiency, 0 carbon emissions in flight, and making planes way quieter for people living near airports.
500%. Zero emissions. That sounds transformative.
It really could be. It points towards a future of much cleaner, quieter regional air travel. It's pushing the boundaries of electric propulsion.
And this innovation extends beyond our atmosphere too, right? 3D printing in space.
Yeah.
They're already doing it on the ISS.
Yeah, printing plastic tools and parts. But
Mhm.
the next step is huge. Developing printers that can work with metals and even regolith.
Regolith.
Yeah.
That's the moon dust, Mars soil stuff.
Exactly. Imagine you're on Mars 3 years from Earth and a critical part breaks. You can't wait for delivery.
Right. You need to make it there.
Precisely. Printing parts on demand, maybe even using local Martian or lunar soil. That's essential for long-term missions, for self-sufficiency. It cuts down on how much stuff you have to launch.
And speaking of using local resources,
Mhm.
RASOR, the robot digging into regolith.
Right. The Regolith Advanced Surface Systems Operations robot. The idea is to develop tech that can actually mine this space soil and process it.
To get what?
Oxygen to breathe, water to drink, even rocket fuel components, maybe materials for construction. It's called In Situ Resource Utilization, or ISRU, living off the land.
That sounds like pure sci-fi.
But it's becoming real engineering. It's seen as absolutely key for making a long-term human presence beyond Earth actually sustainable and affordable.
Okay, and communicating across all that distance. DTN, delay disruption tolerant networking, a solar system internet.
Yeah, basically. You can't just ping a server on Mars like you do on Earth. The delays are huge minutes, even hours. And connections drop as planets rotate, spacecraft go behind the sun.
So DTN is built for that.
Exactly. It's more like a store and forward system. Data gets broken into bundles, and the network holds on to them, passing them along node by node, maybe through relay satellites whenever a connection is available, until they reach their destination. It's robust, designed for those long delays and interruptions.
Makes sense. And to send more data faster, they're using lasers.
Yeah.
Optical communications.
Yes. Missions like LRCD and DSOC are testing this, encoding data onto laser beams instead of radio waves.
And the advantages.
Bandwidth. Loads more data, like 10 to 100 times the data rate of current radio systems. Think high-definition video from Mars, huge scientific data sets. Lasers are the future for depth space communication. And, connecting this back, it's fascinating how solving these really hard space problems, like surviving near the sun or communicating across planets, often leads to breakthroughs that spin off into totally unexpected uses back on Earth. Materials, computing, medicine. It's this knowledge dividend. That's a huge, often unseen benefit.
That's a great point. Okay, so NASA's pushing the envelope. But while they're doing that, there's this whole other world opening up, right? The private sector jumping into space travel.
Yeah.
Specifically, space tourism.
Yeah, it's exploded in recent years. And the definition is pretty simple. People paying to go to space for fun, essentially.
For the view, the weightlessness.
Yeah.
Just the sheer craziness of it.
All of the above, that unique experience. And it actually started earlier than many people think.
Right, Dennis Tito, April 2001. First paying space tourist. How much did he pay?
The reports say around $20 million for a week on the ISS flying up on a Russian Soyuz.
20 million. Wow. And NASA wasn't keen at first, were they?
No, initially they were strongly opposed, but by mid-2001 they started talking about the issues and opportunities, a gradual shift.
So Tito opened the door. Did others follow quickly?
Between 2001 and 2009, yeah, 7 more tourists made 8 flights. Charles Simonyi went twice. All on Soyuz, all brokered by Space Adventures. Prices stayed in that $20–25 million range.
Any other firsts in that group?
Anusha Ansari became the first female space tourist in 2006. But even before Tito, you had precursors, right?
Like,
Well, the Soviets flew cosmonauts from allied countries. And the U.S. shuttle had payload specialists, non-NASA folks flying for specific experiments or employers, like Charles D. Walker flew for McDonnell Douglas, supposedly cost them $40K.
20,000 versus 20 million. Bit of a difference.
Just a bit. And remember, the Teacher in Space program with Krista McAuliffe tragically ended by Challenger, but it showed the idea of non-professional astronauts was there.
Yeah. And I read that these people often don't like being called tourists.
That's true. Many prefer private astronaut or private researcher. They point out they did training, often ran experiments. They weren't just passengers.
So it's about contribution, not just sightseeing.
Exactly. That's why you see official terms like NASA's spaceflight participant or the FAA calling them commercial astronauts. Language matters here. And zooming out, you see how these early private flights, even though they were super expensive and rare, really cracked open the door. They challenged the idea that space was only for governments and highly trained career astronauts. It set the stage for everything we're seeing now. It really makes you ask, what is an astronaut today?
Good question. Okay, so if you did have a spare $450,000 or maybe $50 million lying around, what are the options now? Let's break down the types of space tourism, starting with suborbital. What's that experience like?
Suborbital is basically a big leap straight up and then straight back down. You cross the Kármán line about 100 kilometers up, the common definition of where space begins, though the U.S. uses 50 miles.
So you get into space, technically.
Yep. You experience a few minutes of weightlessness, get an incredible view of the Earth's curvature and the blackness of space, and then you come back down. The whole flight is pretty short, maybe 90 minutes for Virgin Galactic, even shorter for Blue Origin's capsule flight.
And who's offering this? You mentioned Virgin Galactic and Blue Origin.
Those are the main players right now. Virgin Galactic uses that carrier plane and Spaceship Two rocket clan system. They had the first commercial flight in June 2023. Tickets are around $450,000.
Okay. And Blue Origin.
They use the New Shepard rocket and capsule. Fully automated, flies up past the Kármán line, capsule separates, floats in space for a few minutes, then parachutes back down. Jeff Bezos was on the first crewed flight in July 2021. They've done 10 human flights as of early 2025. Pricing isn't usually public, but it's thought to be comparable, maybe a bit higher initially.
Were there others trying this?
Oh, yeah. Scaled Composite Spaceship One actually won the X Prize back in 2004 for doing it first. And other companies like X-Core Aerospace had plans, but they didn't make it. It's a tough business.
Okay, so that's the quick up and down. What about orbital tourism? That's the ISS trip level.
Right. Orbital means getting high enough and fast enough, about 17,500 miles per hour to actually circle the Earth. You're talking altitudes over 400 kilometers, staying up for days, maybe even weeks.
So way more complex, way more expensive.
Massively. Needs a much bigger rocket, more life support, complex rendezvous if you're going to the ISS. It's a whole different ballgame.
Who's doing orbital trips now?
SpaceX is key here, with their Crew Dragon capsule. They flew the Inspiration 4 mission in September 2021, 4 civilians orbiting for 3 days. No professional astronauts on board.
That was a big milestone. How much did that cost?
Reports suggested around $50 million per seat, paid for by billionaire Jared Isaacman.
Wow. And Axiom Space. They use
Yeah.
SpaceX too.
Yeah, Axiom charters Crew Dragon flights to take private crews to the ISS for longer stays, maybe 10 days or so. They've flown several missions already, X-1 in 2022, X-2 in 2023, X-3 in 2024. With a 4th planned, those seats are reportedly around $55 million. NASA actually supports this, hoping it builds a commercial market for low Earth orbit.
Interesting. So NASA sees value in it. Anyone else in the orbital game?
Boeing's Starliner, developed under the same NASA program as Crew Dragon, also has the option to sell seats to private passengers eventually. And then there's the Polaris program, also funded by Jared Isaacman.
The Inspiration 4 guy. What's Polaris doing?
It's a series of 3 missions pushing the envelope. Polaris Dawn in late 2024 did the first commercial spacewalk and flew higher than any human mission since Apollo, like 1,400 kilometers up.
A commercial spacewalk, that's new.
Totally new territory. And the final Polaris mission is supposed to be the very first crewed flight of SpaceX's Starship. So really ambitious stuff.
Starship.
Yeah.
But like suborbital, some orbital plans haven't worked out.
Right. Bigelow Aerospace had plans for inflatable space station modules for tourism, never quite got there. Orion Span proposed a luxury space hotel called Aurora Station. Also didn't happen. It's still very challenging.
Okay, and the final frontier, literally, lunar space tourism, going to the moon.
That's the ultimate goal for some. Trips around the moon, or maybe even landing one day. Nothing's launched yet, obviously, but there are plans.
Like the Dear Moon project.
Yeah, that was SpaceX again, using Starship, funded by Japanese billionaire Yusaku Maezawa. The plan was to take artists on a loop around the moon for about 6 days. Unfortunately, that specific project got canceled in mid-2024.
Ah, shame. Any other moon trips planned?
Well, Dennis Tito, remember him, and his wife have booked a similar circumlunar flight on Starship. And Space Adventures, the company that brokered the early ISS trips, has advertised a lunar loop mission called DSE Alpha.
For how much, let me guess?
A cool $100 million per seat is the reported price.
Good grief.
Yeah. And again, some lunar plans, like Golden Spike's landing idea, have fallen by the wayside, too. It's incredibly difficult and expensive. But what's really interesting is seeing these distinct market tiers emerge, isn't it? You've got the quick taste of suborbital, the extended stay of orbital, and the ultimate adventure of lunar. It's like comparing, I don't know, a day trip, a week-long vacation, and an around-the-world expedition. Different experiences, different price points, shows the market is starting to diversify.
Definitely. And all this activity, it's not just flights, right? It's creating a whole space economy. How big is that, and what does it even include?
The term space economy is pretty broad. The OECD defines it as basically everything that creates value from exploring or using space. That includes the rockets, the satellites, the ground stations, but also the services derived from space, like GPS, satellite TV, Earth observation data, and the scientific knowledge gained.
Okay, so it's huge. How does space tourism fit in?
It fits into a category sometimes called space for space activities happening in space, for use in space. This is different from a space for Earth, like telecommunications satellites, which currently make up most of the revenue.
But space tourism is growing fast.
Incredibly fast. The market was valued around $600 million in 2021. Projections estimate it could grow at something like 37% per year through 2030. We're talking potentially tens of billions of dollars.
37% growth. That's massive.
It is. And remember, even back in 2010, forecasts predicted it could be a billion-dollar market within 20 years. So the potential was seen early on. The U.S. market especially is a big driver.
And this is part of a bigger trend, right? More private investment, more government interest. People talking about $1 trillion space industry by 2040.
Exactly. There's a convergence of factors falling launch costs thanks to companies like SpaceX, miniaturization of technology, growing government and private investment. It's creating this real momentum. And the hope, for tourism specifically, is that costs will continue to fall as technology matures and competition increases.
Making it maybe slightly less unaffordable.
Eventually, perhaps. And you're even seeing plans for dedicated destinations. Orbital Assembly Corporation is planning space hotels, Voyager Station for 400 people, Pioneer Station for 28.
Actual hotels in orbit.
That's the plan. Places for tourists to go, not just the ISS or a capsule. So the vision includes job creation, maybe inspiring kids about science, driving more innovation, a whole positive feedback loop for the economy. And stepping back, this economic boom really signals a fundamental change, doesn't it? Space isn't just for superpowers anymore. It's becoming a commercial domain, a new frontier for business. And that raises huge questions about how this growth is going to ripple through everything, global industries, geopolitics, maybe even just how we think about Earth's resources. It's a major shift.
Okay, but it can't all be smooth sailing and trillion-dollar projections, right? There must be challenges, criticisms.
Oh, absolutely. Big ones. Legality, environmental impact, ethics, public perception. It's definitely not without controversy.
Let's start with the legal side. Space law. That sounds complicated. Is there even a framework for tourism?
It's evolving. The foundational treaty is the Outer Space Treaty from 1967, way before space tourism. It says nations are responsible for launches from their territory and for any damage caused. It also says space is free for exploration by all, but can't be claimed by any nation. Resources going back are yours, though.
So, written for the Cold War space race, basically.
Hmm.
How does U.S. law handle commercial flights?
The U.S. passed the Commercial Space Launch Act back in '84 to encourage private industry. The FAA licenses launches, mainly focused on protecting the public on the ground. Then, in 2004, an amendment basically said passengers fly at their own risk, acknowledging the danger.
Informed consent,
Right.
essentially.
Right. New Mexico even passed a specific law giving spaceflight companies liability protection if passengers sign waivers, except for gross negligence. But the whole framework is straining. Well, think about liability if something goes wrong internationally. Insurance, consumer rights, passenger safety standards. What about space traffic control, environmental rules? The 1967 treaty didn't anticipate any of this commercial activity. The FAA even stopped issuing commercial astronaut wings in 2021, just listing names online now, recognizing the old definitions don't quite fit. It needs updating.
Okay, and the environmental impact, that seems like a big one. Rockets burning fuel.
It is a growing concern. There was a study back in 2010 looking at hybrid rockets, the kind Virgin Galactic initially used. It suggested that just 1,000 suborbital flights a year could dump enough black carbon or soot high in the atmosphere to potentially affect climate and the ozone layer.
Black carbon, like diesel exhaust.
Similar stuff. High in the stratosphere, it absorbs sunlight, warms things up. The study suggested it could cool the tropics slightly but warm the poles and maybe damage the ozone layer. It wasn't a prediction, more a sensitivity test, but it raised flags.
Has there been more research?
Yes. A 2022 study basically confirmed that routine space tourism could have substantial effects and said it should motivate regulation. Different rocket types have different emissions, but launching anything repeatedly has an impact. It's an area needing much more research and likely rules.
And what do regular people think? Is everyone desperate to go?
Not necessarily. That 2018 Pew survey found that while people are fascinated, they want the unique experience. The View, only about 43% of Americans said they were actually interested in going themselves.
Maybe the risk puts people off. Astronaut Megan MacArthur warned tourists it's uncomfortable and risky.
That's likely part of it, plus the cost, obviously. And there's ethical criticism, too. Remember Günter Verheugen from the European Commission calling it only for the super rich, saying it went against his social convictions?
Right, and Prince William, saying billionaires should focus on saving Earth instead.
Exactly. That comment got a lot of attention. It taps into this broader debate. Should we be spending vast sums on sending a few wealthy people to space when we have urgent problems like climate change right here? It's a valid question about priorities. And tying it all together, these issues with the legal gaps, the environmental worries, the ethical questions, they all point to this fundamental challenge. How do we make space exploration and tourism sustainable and maybe eventually accessible? It's not just about can we do it technologically, but should we, and how should we do it responsibly? That conversation is only just beginning, really.
Wow. Okay, we have covered a lot of ground today, or maybe a lot of space.
Definitely launched into it.
We went from NASA's big science goals back to the moon, aiming for Mars, studying our own planet and the universe and the amazing tech they're inventing.
Like quiet supersonic jets and laser communications.
Right. Then we jumped into the whole space tourism boom, suborbital hops, orbital stays, even dreams of lunar trips.
Wow.
Talk to players, prices, those eye-watering prices.
And the huge economic potential driving it all, that trillion-dollar industry prediction.
But also, crucially, the tough questions. The legal maze, the environmental footprint, the is this fair?
Unnecessary counterpoints.
So it leaves you thinking, doesn't it? As space travel becomes more, well, normal, I guess, for some. What kind of future are we actually building up there and down here?
Yeah, will it just be a playground for the rich? Or can the exploration, the technology, the perspective, can it somehow benefit everyone in ways we haven't even thought of yet?
That's the big question, isn't it? Something for all of us to ponder. Thanks for joining us on The Deep Dive. We hope this gave you some things to think about as humanity continues its journey outwards.